Okay, so we'll start Unit 3, which is radical expressions and equations. Unit 4, actually. So you'll learn about radicals, mixed radicals, entire radicals, simplified radicals, radical expressions, equations, rationalizing denominators, and conjugates. So some exponent laws that will be beneficial to remember is powers of powers. When bases are same, we are multiplying, you add the powers. You're dividing, bases are same, you subtract the powers. Power of a power, so m times n will happen. So a to the power of 3 to the power of 2 will be a to the power of 6. Powers can be distributed because this is a to the power of 1. 1 times m is m, and then b times m, 1 times m is m again. Same thing, because 1 is the power, you can distribute it. Anything to the power of 0 is 1. We briefly touched on negative exponents earlier during mental math, remember? So when you have 3 to the power of negative 2, it'll be 1 over 3 squared. Remember? Flip it. So it'll be 1 over 9. Perfect squares and cubes. These are the ones that you kind of look at the numbers and you're like, oh yeah, it could be a perfect square or cube. In the non-calculator section, just remember that you're not allowed to have this sheet. Yeah. Okay. Lesson 1. Working with radicals. Everyone has a note package. I did give it out. So this is something you've done in 10C, parts of radicals. So cube root of 8 is 2, right? You can use a calculator if you want. The function that you use your calculator for is math 5, and then it gives you something like this, and then you put the number 3 over here. So we can do that. So it'll be it'll be math, and then you have 5, and then you put 3, and then you put 8 over here. You press enter and you'll get 2. Okay. Same thing over here. Try putting this in your calculator. And your answer would be 3. Now, when you have a negative,
shouldn't the second one be positive or negative?
it could be, yeah.
Or would we be marked on a test if it doesn't say anything about it? Like if it said 4, like, or 81 square root 4, whatever root it's called, 4th root, would you be marked on the test if we didn't put the positive negative?
No. Just thinking. Let's write plus and minus over here, and then I'll think about what to do on the test. Okay, this one. 5 is our thing, and we have a negative over here. So what will the answer be for this one? Negative 3. And what if it was square root of negative 243?
It wouldn't work.
Wouldn't work, right? It worked in this case because it's an odd index. Okay, so this is the symbol you use. Nth root of x is how we say it. So 5th root of negative 243 is how you'll say it. It's basically you're asking yourself what number can be multiplied by n to give you x. So what can you multiply by itself 3 times to get 125? 5, right? So a few words. Radicand is what's over here. Can we turn to our neighbors and say radicand?
Radicand.
Okay. And then this is our index. And the whole thing is a radical. Okay? So, let's radical in the form 1 nx. So we don't have any other number but 1 because 1 always exists, right? So it's just a product of 1 and a radical. Okay, so examples will be square root of 2. It'll be square root of 126. Cube root of 49, right? Mixed radicals are radicals in the form a n of x, which nth root of x, which means we're just doing product of a and a radical. Okay, so 2 root 2, 3 root 71, 15 root 3. Okay, now you might be given questions in which you need to convert something to radicals or mixed radical or entire radicals. That's why we need this definition. Okay, so mixed radicals. Now they're asking us to convert mixed radicals to entire radicals. We're given mixed radicals, we need to put it in, right? So put the index of the radical as an exponent. So the index over here is 2. Whenever you don't have something, it's just square root, okay? So 7 squared times 3, then you put the radical or the index over there, and then you get 49 times 3, which is 147. Okay, same thing over here, index is 2, so a to the power of 4 to the power of 2, a stays as it is, it's a to the power of 8 times a, which is a to the power of 9. Same thing for the next one, 5b cubed, right, times 3b squared, put cube root over there, 5 cubed is 125, b cubed is b cubed, 3b squared, 125 times 3 is 375, bases are the same, we are multiplying, powers will be added, which will be 3 plus 2, and that's 5. Okay. Okay. Now we'll do some examples of going from entire radical to mixed radical. So you want to write your radicand as a perfect factor. So it could be perfect square, cube, etc. And then you rewrite it. So 108. Think about the factors.
27 and 4.
Hmm?
No, it's wrong. I was thinking cube root thing.
You can use a calculator. You can do 108 divided by, start with the smallest perfect square. Divide by 4, will it work? Divide by 9, will it work? Divide by 16, will it work? 4 and 27, okay. Okay, I can take out the 4. I'll have 2 square root 27. Can I split 27 into a perfect square? 3 and 9, so it'll be 9 times 3. Take out the 9. Square root of 9 is 3, so 2 times 3, root 3, which is 6, root 3. Now, could I have just done it as, write down all the perfect squares. We have 1, 4, 9, 16, 25, 36, right? And then started from the bigger one. Because if it was 36, I could have just done 36 times 3, right? And then 36 is a perfect square. Do square root of 36 and you'll have 6 square root 3, right? Either way works. Okay. Let's try part B over here. So they want us to have it in the simplest form. Whenever they say simplest form, it means mixed radical. In the simplest form, so that like you cannot stop over here. You'll have to have it in the simplest form. Now 32, that's easy. 8 and 4 or 16 and 2, right? Oh, it's cube root. Yeah, so it'll be 8 and 4. So we take that out. Cube root of 8 is 2. Put that here. 4 and cube root negative 4, cube root of 4. Okay. Make sure when you're taking it out, do the index, like whatever the index is asking you to do. Don't just take the number out and leave it as it is. Okay. I want you guys to try part C, and then we'll move on. So cube root of 108, what can we split it into? 27 and 4, yeah. And then, 27, cube root of 27 is 3, so I can take that out, do 2 times 3, have cube root of 4, 2 times 3 is 6, and then that's it. Do you guys want me to do any question from like part A, B, or from here? Okay. So, when it comes to variables, things get a little tricky, but we're using the same idea here. So square root of x squared is just x, right? You can think of it as square root is just whatever to the power of half, right? So x square root is x squared to the power of half, which is just power of a power. 2 times half becomes x to the power of 1, right? So that's the math behind it. X to the power of 4 is x squared. X to the power of 6 will be x cubed. X to the power of 3, cube root of x to the power of 3 will be x. Cube root of x to the power of 6 will be x squared, because x squared times x squared times x squared is, bases are same, we are multiplying, powers get added, x to the power of 6. Cube root of x to the power of 9 will be x cubed. Now what if the variable isn't a perfect square? So if we are doing square root of x cubed, what will we get? This is the question we're working on. Can we convert it into a mixed radical?
You could do x squared, or like x2 times x.
X squared times x can be written as x cubed, right? Now this is a perfect square, so we'll take it out, and it'll be x square root x. Okay, same thing over here. We can do x to the power of 4 times x, take out the x to the power of 4, which is x squared times root x. Same thing, x to the power of 6 times x. And do the square root of it, you will get x to the power of 3 times root x. Okay. Now x to the power of 5 will be this, right? Do the function on x to the power of 3, which is x times cube root of x squared. Same thing over here. Cube root x to the power of 6 times x squared. Take that out, we get x squared times cube root of x squared. what will the answer to the last one be? Good.
And then 3x
3x?
or x cubed times cube root x.
Good. Okay, so we're potentially just dividing 9 divided by 3.
X cubed times, or isn't that just x?
What is x?
Well, x cubed times the cube root of x?
No,
Hmm.
because it's x to the power of 3 times x to the power of 1/3, right? Bases are same, powers get added because it's multiplying, so it wouldn't be the same. What's 3 plus 1/3? Hmm?
3.3 repeated.
Okay. Okay, so when it comes to simplifying radicals with variables, what's a rule that you can write for yourself to remember what to do? Can you tell yourself?
Just you have to make it divisible by the power or the.
A perfect square or cube if possible. And then divide it by the index, or divide the exponent of the variable by the index, right? Okay, so let's do a few examples. We have cube root of x to the power of 14, right? So we need to break it down to have one as a perfect square and the other one which is not a perfect square. What can be the perfect square? So think of what's the closest multiple of 3 that's closest to 14. Multiple of 3. 12. And then you're left with x to the power of 2. So this is a perfect cube, which will be 12 divided by 3, which is 4x to the power of 4, x squared, and cube root of x squared. Okay. Same thing over here. Now this 12 is already a multiple of our index, which is 3. That means all I need to do is 12 divided by 3, which is x to the power of 12 divided by 3 is 4. X to the power of 4. Make sense? Any confusions about this? You guys get why I wrote 12 over here and why it was easy for me to detect that? So I looked at my index, which was 3. I looked at the multiple that's closest to 14, which was 12, which makes this a perfect square, right? Or sorry, perfect cube. Now I did 12 divided by 3, which gave me 4. And I left this as it is because 2 divided by 3 gives me a decimal. I don't want that. Okay? Because essentially, cube root is just 1/3. Power of 1/3, right? Okay, so something new for 20-1 is that whenever you have leftovers, you look at the largest multiple of the index and then you divide it by the index itself, okay? Like what I just told you guys. So an example is square root of x to the power of 11. What's the multiple that's closest to 11? A multiple of 2 that's closest to 11, 10. So we split it to 10 and 1. Since 10 is divisible by 2, I take it out, right? 10 divided by 2, that's 5. And I just have x as it is over here. Okay, So let's try this one now. They're together. We have a coefficient and a variable. So we have square root of 75. If this kind of overwhelms you, you can just do 75 times square root of x to the power of 5, and we can split that. So what's the perfect square that makes up 75? 25 and 3. So 25 squared times 3, and then we have index of 2. What's a multiple of 2 that's closer to 5? So it'll be x to the power of 4 times x. Don't forget about the x over here, right? Now these are my perfect squares, so I'm going to take them out. Can I just write 25 and root 3 over here? No, I have to perform the function, which is square root of 25, right? And then square root of x to the power of 4 is x squared root x, okay? 5 times root x is x squared is just 5x squared root 3x. Now because the radical is the same, or the index is the same, we can write it together like that. Make sense? Okay, next one. 32 can be split into 8 and 4. Can I have a perfect square that's bigger than 4? It's 16 and 2. That's my square root, and then this one is going to be x to the power of 8. Do I need to split this, or is square root of x to the power of 8 a perfect square? It is a perfect square because 8 is a multiple of 2, right? So I can just do x 8 to the power of x to the power of 8 divided by 2, right? And that's x to the power of 4. And because this is a perfect square, it'll come out, which will give me 4 square root of 2. And then you just multiply all this, which will be 4x to the power of 4 square root 2.
I have a question. Because unless I did something wrong, I did 4 and 8 instead of 16 and 2.
So if it was 4 and 8, you factor the 2, you're left with 8. Now 8 is 4 times 2 as well, so you'll take out the 4, and it'll be 2 times 2 to the power
Okay, that makes more sense.
square root 2, and then this is 4 square root. Yeah, simplified form, always simplified form. You want it like this, not like that. Okay, your final answer should be this. Okay.
How come we can't just put 8x in the root?
What do you mean?
X, like, instead of, so you solve it, and how come I can't just do, like it was 4 on the outside? How come you can't, like, have 4 root 2x 8?
It's just better that way because you don't have a radical on there. Like, the numbers are split, but it's fine if it's the other way too. Yeah. Okay, next question. We have 24, cube root of 24. We need to look at perfect cubes this time. (24) can be split into 8 and 3, and then y to the power of 5, cube root of y to the power of 5 will be what? What can it be split into? Good, 3 and 2. So y to the power of 3, cube root of y to the power of 2. Now this and this are perfect cubes, so this would be 2 cube root of 3 times y cube root of y squared, and then 2 times y, which is 2y, and then because this have the same index, you can combine them. So it'll be 3y squared with an index of 3. Okay, and that'll be your final answer. Okay, next one. Now we have index of 4. So 32. -3 stays the same. We have index of 4. 32 times 4, 6, 9. 16 times 2. Yeah, good. So it'll be 16 times 2. And then this one would be c to the power of
4 and 5.
could, but 5 can also be simplified, right? Largest multiple of 4 that's closest to 9. C8 times C1. So we can take out 16 and c to the power of 8. 4th root of 16 is? When I take this out, what will I have?
2.
2, and then I'll have 4th root of 2 times, take this out, what will I have?
You'd have 2 on the outside?
C squared, because C8 divided by 4, right, is 2 times 4th root of C. Now, these are my like terms, so I'll place them together. -3 times 2 is -6C squared. And then this times this is 4th root of 2C. Just remember, you guys, make sure that you're differentiating this. Like, I shouldn't be confused that is the 4 the index or is it with the 6, okay? So when you're writing it on the test, just be mindful of that. Okay, I want you guys to do question A, C, and D, and we'll discuss them.